Okay, so for the distance formula, that is a formula that we're going to use when given 2 points. And when you're given 2 points, they are in the form of x, y, and if we have 2 of them, we need to be able to tell them apart. So we're going to call one of them x1, y1. We're going to call one of them x2, y2. They're always going to go in alphabetical order, so x, then y. Here's the formula. It's kind of a big one that you are going to need to know, and I would put in your blue book, because if you get this wrong, if you write the formula wrong, then your entire problem is wrong and no partial credit. So x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So if we look at example number 3, it says find the length of segment DE using the distance formula. So for this one, instead of putting just D equals for the distance formula, we're going to put DE equals, because we're finding the length of DE, or the distance between those 2 points. So we're going to write out the formula first, and I would do this on every problem. It's really going to save you some points. And the other thing that I would do before I begin anything else is I would label these points with their coordinates. So this would be 1, 2, and this would be 3, -2. So if we plug in, we want to say, what is x2? x2, well, we first need to label these. I would say x1, y1, because I'm just going to say that that's my first point, and I'm going to say this is x2, y2. I'm going to say that that's my second point. Now, it does not matter which one is point 1 and point 2. It does matter that you go xy, xy. So x2, in this case, is 3, minus x1 is 1 squared, plus y2 is -2, minus y1, which is 2, squared, equals, order of operations says to do your parentheses first, so 3 minus 1 is 2, so we have 2 squared, plus -2 minus 2. Now we can change that to plus a negative. And when we do that, -2 plus a -2 is -4. Notice I put that in parentheses because of the negative. So if I simplify this down, 2 squared is 4, and -4 squared. Now if I square anything, I'm going to get a positive, because a positive times a positive is a positive, but a negative times a negative is also a positive. So if we did -4 times -4, we would get a positive 16. So DE is going to equal the square root of 20. And if you type that into your calculator, you're going to get approximately 4.5 if you round to 1 decimal place. That is how you use the distance formula. Part B says to draw a right triangle and find the length of DE using the Pythagorean theorem. So we're going to do the same problem, just a different way. So let's create a right triangle first. DE is going to be the hypotenuse, so we need to draw in some legs that would create a right triangle. So now we have a nice triangle that we need to put the lengths on for the legs, because we can count the boxes for that, and then we're going to find the hypotenuse. So if you look at the vertical leg right here, that covers 4 boxes. So the length of that leg is going to be 4, and the length of this horizontal leg is 2 boxes. So that length is going to be 2. And we want to find the hypotenuse, which is DE. So I'm going to call that C, just because in our Pythagorean theorem, C is always the hypotenuse. So again, I write the formula first. C squared equals A squared plus B squared, and I plug in. C is what we're finding. A and B are 4 and 2, or 2 and 4. Again, the order does not matter for the legs. 4 squared is 16. 2 squared is 4, and if you combine like terms, you get c squared is 20. But again, we don't want c squared, we want c, so we need to square root both sides, and when you square root c squared, the square and the square root cancel. They undo each other, they are inverses of each other, so you just have c equals the square root of 20. What you notice is the same as when we used the distance formula up here. If we type that into our calculator, again, we would round to 1 decimal place and get 4.5. So the big question is, can I leave it the square root of 20, or do I have to give 4.5? And that really just depends on the directions. If they tell you to leave it in radical form, you need to leave it in the square root of 20. Or if they say leave an exact answer, you leave it the square root of 20. But if they say to round to the nearest tenth, that means round to 1 decimal place, so you would type it into your calculator and round to 4.5. Okay, on to the checkpoint. Find DE 2 different ways. So, we have learned that we can, given 2 points, plug them into the distance formula. And we have also learned that given a triangle, you can do the Pythagorean theorem. Both of which we can do from this picture. So, let's do the distance formula first. I need to label the points x1, y1, and x2, y2. Now be careful, this is a 3. Not an 8. I know it can be a little bit deceiving there, but that is a 3. So let's plug in x2 minus x1 would be 3 minus 1 squared plus y2 minus y1 would be negative 2 minus 5 squared. 3 minus 1 is 2. Negative 2 minus 5, again, we can change this to plus a negative. And negative 2 plus negative 5 is negative 7. When you square a positive or a negative, you get a positive. So 2 squared is 4, and negative 7 squared is 49. Combine like terms, and you get the square root of 53. That is an exact answer, left as a radical. If we wanted to type that into our calculator, we would get 7.3. We know it's between 7 and 8 because the square root of 49 is 7, the square root of 64 is 8, so it has to be between those two numbers. Okay, so on to the Pythagorean theorem. We are basically going to verify that we have done our distance formula correctly. So we need to create a triangle. There's our triangle. And I like to shade it in just so you can see that it's a nice right triangle. And then we need some lengths. Well, because this leg is exactly vertical, we can count the boxes, and you should see that there are 7 boxes, so that is 7 units long. And this is 2 boxes, so 2 units long. We are finding the hypotenuse, so that will be c. So when we plug in, we'll have c squared equals 7 squared plus 2 squared, or 2 squared plus 7 squared. So you get 49 plus 4, so you get 53. And again, if you square root both sides to get rid of that square, you get the square root of 53, which is approximately 7.3. Now again, just to reiterate, you have learned 2 formulas today. You have learned the distance formula, and you have learned the Pythagorean theorem, both of which should be written in your blue book so that you can have them available for you on the test or on the quiz, and make sure that you have your definitions, your diagrams, your formulas, all of that stuff should be in your blue book.